Welcome back, and we're going to talk about convex and concave polygons and a lot of different angles and what it means to be regular. We're going to start with this first one right here. This one right here, we're talking about whether polygons, which are things made of straight sides that are closed, which all of these here are, which ones are convex and concave. I like to say something is concave if it caves in anywhere, even if it's just one little spot where it goes in. So this one is concave, and so is this one up here, because they go in at some spot. These here, these 1, 2, 3, 4, we will call all of these convex. These are more of your normal shaped polygons. If you extend any side of the shape, it'll never go in the interior. It's another way of saying if something's convex, because obviously if I extend this side over here, I went inside. So any little inward movement makes it concave. Next, whether something is regular or not. It is regular if all sides are equal and all angles equal. This parallelogram that I drew here is obviously a no. This is a small angle and that's a big angle. So the angles are clearly not all the same. Plus this side is long and this one's short. Not all. I realize that, yeah, these might be the same, but to be regular, all the sides must be the same. Tried my best to draw 4 here that are regular. To be regular, it means all 5 sides of that pentagon are the same. This one's a hexagon, so all 6 sides. Equilateral triangle, all 3 of its sides are the same, and here all 4 sides obviously of a square are the same. But to be honest, it's not just the sides, the angles have to be the same. All 5 angles of the pentagon are the same, all 5 angles of the hexagon are the same, and all 3 angles of the triangle and all 4 here of the square are the same, which makes it regular. All equal sides, all equal angles. Next, this is a pentagon. It has 5 sides, so the number of sides is 5. If you ever need to find out what its 5 angles add up to in a convex, meaning no cave-ins, not necessarily regular, what I do is use this fact that there's 180 degrees in a triangle. Pick one vertex and draw all the diagonals from that one vertex. What it does is it divides the shape into triangles when you do that. This shape, 5-sided shape, ends up having 3 triangles. So if each triangle is 180, so if these 3 angles add to 180, these 3 angles add to 180, and the 3 angles in that last one over here add to 180, I will have covered in all the angles, colored in all the angles of the pentagon. So I have 3 triangles, 180 each, so all 5 angles would add to 540. Now there is a formula for this, if you'd rather do that instead of dividing it into its triangles. Formula is 180 times n minus 2, where n stands for the number of sides. So if this is a pentagon, n is 5, so it's 180 times 5 minus 2, which is essentially what we did here anyways. 180 times 3 for the 540. Okay, so 180 times n minus 2 gives you the sum of the angles in any polygon, any convex polygon. But what if I just wanted to find one? Alright, so what I need to do is I first need to find what all 5 add up to. So, and this is a pentagon and it's 5. I'll do what we did before. Here was our formula. And I do 180 times 5 minus 2, so that's 180 times 3. That's 540. So all 5 of these angles, and if it's regular, they're all the same, add to 540. So I simply divide it by 5, because there's 5 of them, to find out that each angle is 108 degrees. Feel free to divide it into its triangles or use this formula to get the sum. but don't forget to divide it by its number of angles to find what each one is. A formula that you could use or put together. Here's the formula for the sum, and if I just simply divide that by the number of angles there are, because if something has 5 sides, it would have 5 angles if it's convex. So we can use that formula and get the answer 108 just as easily. All right, last but not least, here was our pentagon. An exterior angle is found by extending one of the sides. We found that the one inside angle was 108. Straight line, linear pair. If I took 180 minus 108, I get 72. So if I created an exterior angle at each spot, at each vertex, if I just put 1 on each side, oops, 72, 72, 72, 72, 72, it adds to 360. And to be quite honest, if you put an exterior angle, one exterior angle at each vertex of any regular polygon, whether it has 5 sides like the pentagon, 6 sides like a hexagon, they will always add to 360, which is interesting, I think. So the formula for one exterior angle is 360 divided by n. All right, in conclusion, let's just make sure you have these formulas. Here are our 3 formulas. Sum, 180 times n minus 2. That gives you all the inside, interior angles. If you want to find one interior angle of a regular polygon, you use the sum and divide it by n. And if you need to find one exterior angle, formula is 360 over n. So without a picture, let's do a regular decagon. Decagon, n equals 10. So the sum, 180 times 10 minus 2, or 180 times 8. Grab my calculator here. When I do that, I get 1440. If I want one angle, one interior angle, I will take that sum and divide it by 10. Because right here, the formula has the sum formula, divided by the number of sides, decagon is 10. That gives me 144. And if I wanted an exterior angle, formula is 360 divided by n. 360 divided by 10 in this case, because it's a decagon, 36. These are all angles, so I should go back and add my degrees. And that is the end of this video.